Right, today we're looking at our quadratic functions in standard form. As a review, here is the vertex form, here is the x-intercept form, and here is our standard form. We have three terms, a quadratic, a linear, and a constant term. What we get for free in this term is the y-intercept. That's going to be 0.0c because a times 0 squared plus b times 0 plus c gives us y equals c. So we have that ordered pair 0c. Like the previous two forms, the vertex and x-intercept, we will need to find the vertex to graph the parabola. The point we get for free from the standard form is the y-intercept. We will plot this first, then we will use the formula x equals the opposite b over 2a to get the x-coordinate of the vertex. We will then use this x-coordinate as the x in the standard form of the function to find the corresponding y-coordinate of the vertex. We will plot this point and the axis of symmetry. We'll plot our 0, c. We'll use symmetry to find other points, the symmetric partner for a y-intercept, and then the counting pattern to find one more additional point. So if we look at the first one, I cover up these two terms. I know my y-intercept is 0, 3. Now I use my new formula, the opposite of b over 2 times a. I do that math, I get -1. I substitute -1 in here where I see x's. I crunch the numbers. I get a +1. So my vertex is at -1, 1. My y-intercept is 0, 3. I use symmetry to find its partner over here, and then I'm going to use my counting pattern. This is my over 1 up 2. This will be my over 1 up 2 times 3. And then I use symmetry again. Here I've got standard form, so I cover these two up, and I know I've got a y-intercept of 0, -12. I could plot that if I wanted to right away. Now I need to find the x-coordinate of my vertex. So I take the opposite of b over 2 times a. This is going to give me a +4. Now here when we graph, we need to adjust our scale. So we're going to have each one of these tick marks represent 2 units instead of 1. So now I need blue. Here's my axis of symmetry at x equals 4. Now I'm going to substitute a 4 in where I see an x, crunch the numbers, and I get a +4. So my vertex is at 4, 4. I can use symmetry here now that I have my axis of symmetry to find the symmetric partner for my y-intercept. And I can use my counting pattern. It's a little tricky here. Over 1 is just halfway. And over down 1 is just halfway. Over 1 is just the remainder of that half. And then I would go down 1, 2, 3. And then I would use symmetry and then connect those dots to produce the graph. Okay, go ahead and take a moment to reflect on the different forms and how we find the x-coordinate of the vertex for each form. Right here we want to determine the extreme value and its location just using the standard form function of our quadratic. So like Friday, we're going to determine does it open upward or downward. Here this is upward because the leading coefficient is positive, which means we have a minimum of blank at x equals blank. Now we use our new formula, the opposite of b over 2 times a, to get 10 over 2, which is 5. So I know my minimum occurs when x equals 5. So now I substitute in 5 for x, crunch the numbers to get my y-coordinate of my vertex. That is my minimum value. Here the leading coefficient is negative, so we know we open downward, which means we have a maximum of blank at x equals blank. We're going to find the x-coordinate first, the opposite of b over 2 times a, get me +4. I put 4 in for x and crunch the numbers to get my y value. and I get y is 23 when x is 4. So my maximum is 23 when x equals 4. Okay, the last thing we're going to do is write our equations, and we're going to amp this up a little bit tomorrow using our leading coefficient and some other information. So it says leading coefficient is -2, y-intercept is 5, and our linear coefficient is 4. So the leading coefficient is a, y equals ax squared, plus b, that's our linear coefficient, x, plus our y-intercept. Here our vertical compression is 1/4. The linear coefficient is 9, and our parabola goes through the point 0, 11. This is my y-intercept, so this is my c value. I have y equals a x squared plus bx plus c. Now there are some for you to try, so go ahead and pause the video and then check your work with what I have here. So we'll do 2 graphing, 2 analyzing our quadratic function in standard form to get our extreme value, and then 2 where we're going to use given information to write our quadratic function in standard form. Go ahead and kind of gauge your proficiency with respect to our I can statements. I can graph a quadratic function in standard form. I can get an extreme value from a quadratic function in standard form, and I can write a quadratic function in standard form given key characteristics.